Hey everybody. Section 9.2 is adding and subtracting rational expressions, or simply put, combining algebraic fractions. Two of your favorites combined into one, algebra and fractions. Try not to be too excited. So the process is shown here in the box. Notice in number one, this word that we say often, factor. So if you can factor a problem, it's always going to be a good idea, and we proved that in section 9.1. So clear back in, I don't know, third grade, somewhere in there, they taught you how to do fractions without calculators. Find a common denominator. That's step two. Simplify the numerators and combine the numerators. So we're just going to use whatever means we can to put the tops of the fractions together and then simplify the final answer, meaning you're always supposed to reduce fractions whenever humanly possible. So let's get to it here. So number one, notice no variables. So yeah, you could do this on a calculator. I'm not saying you're not allowed to, but let's go through the process so it'll help you out with these other ones. So I'm looking at a denominator of 15 on that last guy. The question is, can I bump those other two up to match him? And the answer is yes. So if I were to go times 3 on that guy, I would have 15. Now here's the key. If you do anything to the bottom of a fraction, you got to do the same thing to the top. I think they taught you that way back when. If I go times 5 on that middle one, that'll give me a 15, times 5 on the top one. So at no point am I going to mess with that third fraction. He's already over 15. So let's clean it up. First one, I get a 6 on top, now 15 on the bottom. Second one, 1 times 5, I get a 5 on top, 15 on the bottom. Third one, we never messed with. Now, common denominators, when they're common, they're common. That's it. That's all she wrote. So I already knew there was going to be 15 on the bottom. The question is what happens on the top. So I see a 6 followed by a plus sign and a 5. So if I add those, I get 11, followed by a minus sign and a 4. If I subtract those, I get 7. And that's it. That's all she wrote. So yes, we would want to try to reduce 7 over 15 if possible. In this case, it does not. All right, number 2, pretty similar, but it has an m. Can't use a calculator for that, but I'm going to start them off the same way. If I go times 3 on the first one, I'll match that 15 that's on the end. Same thing on top. If I go times 5 in that middle one, that'll match the 15 on the end. Same thing on top. Of course, now here's the difference. The first one has now become 15m, but the other two fractions do not have an m. Easily fixed. I'll put an m with that second one. Same thing on top. I'll put an m with the third one. Same thing on top. So do they all say 15m on the bottom? Yes, they do. So here's one thing we can do. We already know that we have a 15m on the bottom. That's our common denominator. So he's pretty much done. So I could just go ahead and look at the top here. I'm going to do that. So if I clean up that top, the first one I got a 6, just like the last problem. This time the middle one has the 5, but it also has an m. And if I multiply that third one out, it would say 4m. So you use your general rules for algebraic simplifying, guys, like terms. Can I add the 6 and 5m together? No. Can I add the 5m and the minus 4 together? Yes. So stuck with the 6. 5m minus 4m is positive 1m. Wow, that's a terrible plus sign. And I got it. So here's the one thing to watch out for at the end here. My advice to you is when in doubt, don't do it. So in other words, can it reduce? If you're not sure, don't do it. Don't take the chance. It would be really tempting to say there's an m and there's an m and I can cross those off. But there's two really good reasons you can't do that. Number one, the top is a binomial. Got the plus sign in the middle. The bottom's a monomial. You cannot cancel binomials and monomials. And the other thing would be this, and we did learn this earlier this year. You can reduce a fraction that has multiple things going on as long as you can reduce them all. So yes, the last one has an m, the bottom one has an m, but the 6 does not. So the only way I can cancel is if everything has something in common. You might think the 6 and the 15 reduces, and that's fine. But the m right here does not have a coefficient I can't reduce. So it has to be all of them or nothing. So that's it for that guy. 6 plus m over 15m. Maybe not too bad. So down here at the bottom, or number 4, it says when in doubt. I was going to say it anyway. And since we're not doing graphing problems, we're not finishing that sentence with graph it out, so it must be factor it out. Okay, now here's why this is important. I have harped on you guys continuously about remembering to do GCFs. That guy has a GCF of 4. I pull the 4 out. There's what's left. This guy has a GCF of 2. I pull 2 out. That's what's left. So here's why that's important. Can you see what's common? So they already have a w minus 4 in common. There's no reason for me to mess with that. Something else I like to do, which you don't have to, I like crossing off the old denominator because I don't need it anymore. I don't want you to accidentally use it twice. So I need the factored version. So I'm going to cross that guy off. Let's go a different color here. So the question is, what's keeping them from matching? First one's got a 4. Second one doesn't. Yeah, how about a times 2? That would make it 4. Times 2 on top. All right, now I'm going to leave the denominator off for a second because we already know it's common. I'm going to write that 4w minus 4 here eventually. But let me rewrite the top. First one had w plus 12. We never messed with it. There was a subtract sign. And then if I were to distribute, I would get 2w plus 8. But here's what gets tricky. What was being subtracted up top there? One of those things or both those things? So my advice to you would be put some parentheses around there. So I knew that I was taking 2 times that whole thing, and that whole thing is what gets subtracted. So if I do subtract now, we've got some sign switching to do. The minus 2w, nobody tends to mess that. But the question is, would you have got that minus 8 right? All right, let's keep going. So if I subtract, combine like terms, I get a negative w, and I would get a plus 4 if I combine the 12 and the negative 8. All right, now here's one of those things where it's like, man, I put in a lot of work. And if you wrote this answer down, I wouldn't be able to give you full credit. Give you most of the credit, but not full credit. Here's why. Do you remember in the last section when we talked about how you could put a negative sign in front of something and it would change the signs? So if you multiplied that back out with that negative 1, you would still get that same numerator that I had a second ago. Well, hopefully you can see why that's important now, because I get a pair of matching w minus 4s, which I can cross off, and the final answer is negative 1/4. Factor and cancel. All right, let's try this other one here. Squeeze this in. So I like doing my factoring underneath. I know I'm going to have a D and a D for that guy, so no GCF this time. 28, 7 and 4. I need a plus 7 and a minus 4 to get that negative 28. Now I'm going to cross him off. You don't have to do that. But again, hopefully you can tell the reason for that. So the reason for that is they both have D plus 7s. That's already common. All I got to do is stick a D minus 4 here, and they match up. All right, next step, multiply the top out. I never messed with the 7D. Hey, this time it's a plus, so I wouldn't have to worry about switching signs. So I don't really have to worry about what happened on that last problem. I could just go ahead and distribute that guy out. And so here's, you can do this, you cannot do this. It doesn't matter to me, whatever you'd like to do. We already know the denominator is common. We already know there's going to be a D plus 7 and a D minus 4. So I got to rate that at some point. But I like to just go ahead and take care of steps 3 and 4 in the process in that box up there, which said to simplify the numerators and combine stuff. So we did the distributive property. Now I know I can eventually add across here. So I could add up my D's. Got my minus 20. And now I can't go any further. If I can't go any further at that point, I'm going to go ahead and write down my common denominator. Now you are allowed to, if you want, that's a 4. Wow, that's terrible. You're allowed to FOIL that bottom out if you'd like. That's just extra work to do. But since the goal is to get a common denominator, you're allowed to leave it that way. Back to that last problem as well. If this guy had been your final denominator, you don't have to distribute it out. You're allowed to leave it. And my advice would be to leave it, right? Because if you go ahead and multiply out this D plus 7 and D minus 4 in this last problem, and you make a mistake, I could count it wrong. Again, though, canceling, no, I don't have anything that literally matches top and bottom here at the end like I did in the last problem. All right, guys, hope you pick up watching this in part 2. Thanks for watching.